Welcome back to Frontiers in Science, a conference in honor of Professor C.N. Young at 100. May we now invite Professor Gong Jiang-Bin up on stage to chair for the afternoon session.
Good afternoon, distinguished guests, colleagues, students, ladies and gentlemen. I hope you had a good lunch and good conversations over the lunch. Welcome back to the afternoon session. Let me first introduce myself. My name is Gong Jiang-Bin. I'm the head of the physics department of the National University of Singapore. It's my great honor to be asked to chair the first three sessions for this afternoon. Our first speaker today is for this afternoon is Professor Tan-Man Chuan. He's my colleague at NUS. Professor Tan received his PhD back about 2006 or 2007. Then he did his postdoc research at the Institute of Advanced Studies at Princeton and later at Caltech. This morning we heard something, quite a lot, about Yang-Mills theory. And now this time we see some real stuff because Professor Tan is going to share with us more about Yang-Mills theory from a mathematical physics perspective. Professor Tan, the floor is yours.
All right, thank you, Prof. Gong, for the very nice introduction. First and foremost, I would like to thank the organizers for this opportunity to speak here today. It's a privilege and honor to be able to speak amongst so many eminent speakers. I apologize that I can't be there physically. I trust everyone is having a good time down in NTU. So without further ado, let me just share my slides. Okay. Right. So since this is a conference in honor of Professor C.N. Young, to whom I'm actually, my work is pretty much indebted to his theory of Yang-Mills, right? And so I would like to tell you guys today about Yang-Mills theory and the physical mathematics revolution of the 21st century. All right. So the outline of my talk will be the following. So I'll start with some introduction about the forces in particle physics, essentially the standard model of particle physics, and how Yang-Mills theory is a central part of describing the forces in particle physics. And then I will go on to tell you how Yang-Mills theory also forms an integral part of more modern theories of particle physics, essentially supersymmetric particle physics, supersymmetric quantum field theory. And then I'll go on to describe how Yang-Mills theory also features in string theory, right? So even string theory is a theory of strings. The endpoints of strings, which are point particles, they actually carry, the characteristics of Yang-Mills gauge fields, which I will, explain a little bit more. And then after telling you how Yang-Mills theory features in these two modern theories in theoretical physics, I will then go on to tell you how the presence of Yang-Mills theory in supersymmetric QFT and string theory leads to physical mathematics. Okay, so physical mathematics is a new term. It's a third discipline, if you will. All right, in a nutshell, it's actually mathematics that comes from physics. All right, so it's a bit different from mathematical physics. I'll explain what it means. It's a 21st century third discipline, that has emerged out of studying the physics of supersymmetric quantum field theory and string theory. And I will show you or explain how Yang-Mills theory plays a very pivotal role in defining this third, discipline of the 21st century. Okay, and then I'll conclude with some of the things that we've talked about. In case you get lost along the way, the conclusion will, sort of summarize everything. All right. Okay. So I consider myself a physical mathematician. Okay, so this is sort of my pet area of research, which means I am a physicist first, and I use physical concepts and principles to derive new mathematics. Okay, so that is sort of what it means to be a physical mathematician. Okay, so I will explain a bit more as we go along. All right, so let us start by talking about Yang-Mills theory and forces in particle physics. So what is Yang-Mills theory? So Yang-Mills theory is actually a generalization of Maxwell's theory of electromagnetism. Okay, it's generalizing electromagnetism so that it can describe the other atomic forces of the universe. namely the strong and weak nuclear forces. Okay, so you have the strong nuclear force, which binds your protons together in the nucleus, and then you have the weak nuclear forces involved in beta decay and interactions that involve leptons, the weak particles which interact through the weak nuclear force. Okay, so the key difference is this: while electromagnetism is an abelian U1 gauge theory, so what this means is that if you look at the Lagrangian for the photon, okay, Maxwell's theory itself, if you look at the fields in the Lagrangian in the action, okay, they're just quantum fields and they're not valued. There are no matrices. You don't see any matrices in the Lagrangian. Okay, so and the reason why there are no matrices is actually implicitly, multiplied to each of the quantum field is actually a 1-by-1 matrix that is unitary, which is it's just a number, right? It's a complex number, and so the theory of electromagnetism, if you look at the Lagrangian, it's that. Now, Yang-Mills is a generalization of that Lagrangian to include quantum fields that are valued with matrices. Okay, I'll give you an explicit example of what I mean in a short while. Okay, and if you do that, when Yang-Mills came up with this formulation of a generalization of the Maxwell's theory to include matrices in the Lagrangian, specifically matrices which are 2-by-2 special unitary matrices and 3-by-3 special unitary matrices. Okay, then you are able to use that Lagrangian to describe the weak and the strong nuclear forces respectively. Okay, so that is the shift. Okay, from going from electromagnetism to describing the strong and the weak nuclear forces. So incidentally, around the late 50s, people